All right, this is going to be a quick answer key video on the substitution method worksheet that we learned about for the substitution method. And the worksheet looks like this. I am planning on going through, three of them with you, and the ones I chose are 1, 11, and 13. So we'll start with number 1. All right, so the substitution method pretty much says if you have a variable solved for, if we go back here, if you have a variable solved for, you make sure that you have one where it's either solved for x or y, and you plug in what that's equal to in for the other equation, and then you can solve for whichever variable is in there. Then once you have one of the variables, you can plug it back into either equation to solve for the other variable, because we always want one x and y. So for number 1, it looks like both of these here are solved for y. So we can use either one. I'm just going to pick the first one and say, put a box around what y is equal to. Y is equal to negative 2x minus 6. So we can plug that in for y over in this equation. And what you're doing is you're setting the two things equal to each other. So it would be negative 2x minus 6 is equal to 3x plus 9. So if you see there, these are both equal to y, so they're both equal to each other. Now what we can do is we can solve for x. So we got to do some steps to solving for x. First of all, get both the x terms on the same side. If you recall, we're going to get rid of the x term over here. Let's say it can go either way. And so this will cancel out the 2x. You have to add 2x to the right side. And you end up with negative 6 left over here. And this would be 5x plus 9. Now we just have to get the x by itself. So we're going to do our Pemdas in reverse. If you recall, Pemdas in reverse, we're going to do any addition or subtraction that we can get rid of. I apologize for that. So we will get rid of this addition by subtracting 9 from both sides. All right, that cancels out here. We have 5x equals negative 6 minus 9 would be negative 15. Okay, and then one more step to divide both sides by 5 to isolate the x. And then x equals negative 3. So we have our x term. But for our answer, we need to have an ordered pair. So we have an x, we have negative 3. We have to figure out what that y is. So what we're going to do with this x here, this negative 3, is we're going to plug it back in for either equation. It does not matter which equation. Just plug it back in for one of the x's. So you have y equals 3 times, we're plugging in negative 3 plus 9. And that would be equal to negative 9 plus 9, which is equal to 0. So y equals 0 here. And we can put that in for our y value, and our answer, our solution to this equation is negative 3, 0. Okay? Now, you might want to slow down those steps a little bit. I explained them, how you would do them, but your goal is to figure out what both the x and the y are, and this substitution method works great if you know what the idea of substituting means. Now, if you really want to check to make sure that's correct, again, you can take that ordered pair, negative 3, 0, and plug the x and the y back in for both equations just to see if they'll end up being equal to each other. If they are, then you did it right. Okay, we're going to make this one a little bit different. These aren't both solved for a variable here. In number 11, number 1 was they're both solved for a variable, and if you look, numbers 1 through 8, they're all going to be solved for y, so you can do the same steps for those. But looking at the last 4, number 11, then only one of them is solved for a variable. So we just have to use that 1. So here we go, we've got that 1 that we can take y equals negative 2. We'll plug in that negative 2 for y. Right in for y. There, draw the arrow because negative 2 is y is negative 2, so we can plug that in for x minus 3 times negative 2 equals 18. Now we want to solve for x, because that's the only variable that's in our equation now, and we can solve for x. So for x, negative 2 times negative 3, we have plus 6 equals 18. two-step equation tells us to subtract 6 from both sides. That's Pemdas in reverse. Get rid of addition or subtraction. You have 4x equal to 12, and then lastly divide both sides by 4. You end up with x equals 12 divided by 4, which is 3. There, like before, we have our x value, 3. Now we just have to figure out that y value. So what I'm going to do is I'm going to take that y value, or that x value, plug it in for, well, this is the first equation doesn't have an x. And actually, we already have our first equation, y equals -2, which our x or our y value should be -2. Well, let's check when we plug in 3 right here. So it'll be 4 times 3 minus 3y equals 18. This is 12 minus 3y equals 18. Subtract 12 from both sides. Okay, subtract 12 from both sides to get that, rid of that positive 12 over there. You -3y equals 6, and when you divide both sides by that -3, y does indeed equal -2. So we have our x, we have our y, we can put them back into the ordered pair. 3, -2 is our solution. Okay, so that's how you do number 11. And I promised I'd go through one more, which is number 13, where if you look at number 13, I think number 14 is similar. Neither of these equations are solved for a variable just yet. So what we have to do here is we have to solve it for one of the variables. And I think I'm going to look at, when you do this, you want to look for one where there is a variable all by itself and it's positive. So you can just do one step to get that variable by itself. And I'm going to look at this one right here. So if I bring that down, -4x plus y equals 6. I'm going to add 4x to both sides so that y is solved for, it's just solved for y. I'm just going to cancel out that. We have 6 plus 4x. And then we also have our -5x minus y equals 21. So now we have our two new equations. So here we're going to cross it out. Here's our two new equations. And we can plug in whatever y is equal to. In this case, it's 6 plus 4x. Plug that in for y. And when we do that, it'll look like -5x we have left in this equation, minus, we're going to plug in, for y, we're going to plug in 6 plus 4x equals 21. Now here's the tricky part. When you have that, you have to recognize that there's a minus sign, so that has to minus both parts. So really it would be -5x minus 6 minus 4x equals 21. Now before we do any Pemdas backwards, you can tell already that we have some like terms. Let's just combine those so we have -9x minus 6 equals 21. And now we can solve for x, where we can add 6 to both sides. This is Pemdas backwards now. End up with -9x equals 27. And then finally divide -9 by both sides to solve for x. And your x is -3. So in our answer here, we'll end up having -3 as our x, and we still have to figure out that y. But with that x, we can plug that in for either equation now, and then solve for y. So what I'm going to do is I'm going to plug it in for this one since it's already solved for y, and I'm going to plug in that for x, and we'll take y to be equal to 6 plus 4 times, instead of x we're doing -3, and that would be equal to 6 plus 4 times negative 3 is negative 12. And then 6 plus negative 12 is actually a negative 6 because you have a positive 6 and you're subtracting 12. So y here equals negative 6. And we have our y. And you can check that by plugging it back into both equations if you'd like. But our answer would be negative 3, negative 6. So this is just the answer key for our first worksheet on the substitution method for solving systems of equations. I showed you 3 of them. You should have ended up with number 1 having the ordered pair negative 3, 0. Number 11 having the ordered pair 3, negative 2. And 13 having the ordered pair negative 3, negative 6. I hope this helps.